Here's 0, 3, 4. I went 0 for the what?
X.
Yep. And here's that YZ plane. X is always 0. So 0, 3, 4. And then my other problem was 2, 3, 4. Let me do that. 2, 3, 4. See, it looks weird here, but you're going straight there. You're like, let me go. Hit the plane. Straight on. So, let's find it.
So we're just finding the value of distance and change in x.
Difference in the x's?
Wouldn't that be what we're looking at then, because everything else is gonna cancel?
Brilliant observation. You're telling me these are just going to be what?
0.
Zeros. Now, what's the square root of 2 squared?
2.
So our answer is just a what? And you might even see a pattern to this. You're like, well then, what you were observing, shouldn't your answer just be that distance right there? Represented by that x coordinate, absolutely. Isn't that cool? That would take, that's the shortest distance from that point to that plane, because we use the same y and z, because we want the shortest distance. And we can do this in any scenario. Cool? Now I got another one. Let's use the same point. Well, let's use an axis. All right. All right, here's your next problem. I'll give you time to write this down. I think there's one like this on a problem set. Can you find the distance from the point 2, 3, 4? Now, these could have been negative coordinates, but I just thought I'd use positives for speed, to the y-axis. Okay. What now? What's happening on the y-axis then? Or I'll specify again, they really mean the shortest distance.
Okay.
X and y are 0?
There you go. And do you remember x in terms of intercepts? Do you remember in the xy plane, right, on the x-axis, y always equals 0? And on the y-axis, x always equals 0? Well, now in three-dimensional space, any point along this y-axis, x is 0 and y is 0. All right, so I'm going to leave a note about that. Here's that y-axis. Remember, YZ plane, I said x equals 0? What's going on the y-axis? X is equal to 0 and z is equal to 0. That's what's going on. Any point on that axis. Like, how about the z-axis? X and y are both 0. All right, so now I'm going to do this in a similar way, but when I find the distance from here, the closest distance, I'm going to use the point 2, 3, 4. But this other point, I'm going to use a 0 for x. Do you all agree? I have to. I'm going to use a 0 for z. I have to. You know what I have to use again for this? All right, I have to reverse when I got to go back to this and go, what was the y value?
3.
You know, that way I'll take the shortest route. And we just do the distance problem. Although I think this takes a little more math than the last one. Let's see. Ready? All right. 2 minus 0 squared. And I know I could have put negative numbers in here. Sometimes just a simple example really helps us see this. 4 minus 0 squared. Okay. That's 0. But these aren't. What's that?
4 and 20 and 16.
So final answer, square root of 20. If you want to break down that radical,
2 root 5.
2 square root of 5, 2 root 5. That's a distance. Awesome. Excellent. Hey, let's do something with the sphere now. Everyone, can you find the equation of the sphere? And if you're wondering, like, have we moved into 12.2 yet? No, we're still in 12.1. We're still in section 12.1. We're almost done with it. You find the equation of sphere. Here's the center. Let's say 4, 5, negative 6. Okay? And let's just say the radius is radius is 7. Set this up. You find the equation of a sphere. The center's 4, 5 now. Okay, we'll plug it all in there. Let's see what we get. Alright, here we go. No square root, right? X minus 4 squared. Y minus 5 squared. Z, what's a minus negative 6?
Plus.
Thank you. And then square that. Oh, and if you can, you notice here, we'll make it a part A, part B problem. I know that the author did the same thing with this problem there when it was in 12.1. Section 12.1 is like a part A, part B. All right, there's the equation of the sphere, right? That they're talking about. All right. Letter B. What is the intersection of the sphere with the XZ plane? I'll just write XZ and then dash. And by this, what is? How about we do two things with this when we come up with this answer? Let's write an equation, but then let's describe it in words. You don't have to draw a picture though, but we'll describe it in words with an equation.
So
So here's this gigantic sphere, right?
Uh-huh.
Somewhere in three-dimensional space, and we're trying to find how this intersects just the XZ plane. Well, you and I know what's going on in the XZ plane, something 0.
Y,
So we're gonna go into here, and that Y right there, what are we gonna do?
0.
Outstanding, everyone agree? That's exactly what we're gonna do. And keep it that simple, we're gonna go in there, we'll let Y go to 0, that's gonna be our equation. We'll keep everything else the same. You might wanna rearrange it though, so it looks prettier. So I'm gonna let Y equal 0. Here's what I'm getting. X minus 4 squared plus,
With the equation of a circle.
ooh man, that was good here, very good, great observation. So I'm sticking it in here, everyone. Alright. Keep this, keep this. But let's rearrange this thing, make it look prettier. Because that's just what number now?
25.
No, that's a 25. So I'm just going to subtract it from the 49. Alright, so I think this will look just a little better. I'll leave this as my answer. What's 49 minus 25?
24.
Alright. And you go, there's my answer. But it's an equation. I think we should add words to this, and I thought you came up with a very good description. What is that?
It's the circle on the XY or XZ plane.
Everyone, here's this gigantic sphere. And great observation, you go, what's the intersection, like what is that? It's like a slice of that sphere. Just one slice, which turns into a what? So a circle. So think of their slicing an orange. Like just one thing gets this really, really thin what? Circle, and that's what it is. And you can go in and go, that's a circle. And that's the answer. Here's the equation, but it's a circle. You want to be more specific? What's the center of the circle? The center is, don't we got to change all these signs?
X equals to 4 and
So 4, now be careful, what's Y?
0.
Good, everyone, you see that? Y is 0. I know it's not written there, but you're like, there's three-dimensional space. In this circle, this center, you got 4, 0, comma.
Negative 6.
Now the radius isn't neat. What's the square root of 24?
6 root 2.
Alright, the radius, that one is the square root of 24. 2 root 6, 2 radical 6. There's our description in words. It's a circle, there's the center, that's the radius, that's the equation. Now everyone, I want to be specific with this question. Does every sphere have to hit every plane? No, so I want to point out, if you did this math, you subtract, when we subtracted the 25, if this number was bigger than this, you would have got a negative value over there, and you'd been like, wait a minute, I can't get the square root of a negative number for radius, and that means it just doesn't intersect that plane. So that's a quick way to realize
So
that.
we don't deal with I in.
That's right. And we're not in a complex number system in this course. You may take in a course where you are. No, we're just in the real number system in here. No I's. I know, and it doesn't even come up in any discussions. There's no like extensions to some of the sections on there.
If it equals 0, does that mean it just touches it?
That's exactly right. That was good. Very good. Hey, any questions on this? Cool. Hey, in your notes you can put 12.2. What's the title of 12.2? Yeah, now the fun begins. All right, we get the introduction. That's fun. Nah, this.
Vectors.
But see, there's people in this room right now, they may be like how I was when I was a student. Some students come in here and are like, oh, I've seen vectors for many semesters. I've been taking physics a few times. So I've seen vectors before, but you might not like me where first time I saw vectors was in calculus 3. And I was like, what is that? And so that's what this is. This section is an introduction to vectors. So we have to define it. Right away, you go, what is a vector? Well, it's a quantity. That's the first thing. And it's a quantity. I want to give you a couple examples. Displacement. That's one example. Displacement. When I say displacement, you can think distance. Displacement, a force. Like a force of 12 pounds, but it is a quantity. So a vector is some quantity that has two things.
Direction.
This quantity has two things. It has a magnitude what do you mean by magnitude? Well, it'd be like the distance, numerical value, the magnitude of the force, 12 pounds. Has a magnitude, but here's the other thing it has. A direction. So that's what I mean, it's important that we go, all right, I need to know what a vector is. If I'm going to be seeing vectors through this all, this is vector calculus from here on out. And it's fun, you can do so much with it. But we need to know what it is. So it is a quantity. All right? It has two things, it has a magnitude and it has a direction. Okay. Well, how could we draw just one example of a vector? Let's draw it. And we can put it in two space. Before we do three-dimensional vectors, might as well just draw a vector. Starts here. I can start at the origin. Let's say when run over to the right and 2 notches up. Good? So I'm going to start here and move a vector. It goes 1 to the right and 2 notches up. I'm going to draw an arrow and stop my arrow right there. So you notice with this vector, it has a particular direction, right? But it also has a particular length to it. And I'll call this vector A. All right, so you're vector A. There's a couple ways to present vector A. You can put an arrow over it. Vector A, that's vector A, and I put a little arrow over it. The textbook puts it in boldface print. That's hard to see on the board, so I'll probably be doing this a lot. Everyone. I'll be like A with an arrow because you can't tell if I put something in boldface print with this chalk. Now, here's the vector. What can I say it equals? These are the components. This is the x component, and this is the y component of the vector. And you're sure components can be negative, but if in this case, aren't they both going to be positive? Because I went to the right and I went up. But if this vector went over there, you're like, well, you went left, so that x component will be negative, the y component will be positive, etc. So what's the x component? 1, 2. Awesome. Hey, let's say I got a vector way over here. I'll call it vector B. But it also went 1 right and up 2. I'll put a 1 here and a 2 there lightly, just so you can see it. Well then, I can write mathematics. Here's the beauty of vectors. But these are equivalent. You're really? Yeah. They're equivalent. They're equivalent. Two vectors, as long as they have the same magnitude and they have the same direction, those vectors are equivalent. They're the same. You mean it can be way over there? Yeah, it's almost like you can slide these. I could take this and slide it over here, right? And you're like, as long as that vector keeps that same direction and the same what? Magnitude. Now, I haven't found the magnitude yet. What does magnitude mean? It means that length. So we're going to need an important theorem to find the length of this thing. Well, what's the notation for the length or the magnitude? We put those bars around. You'll see that a lot. When we do that, I'm not talking about that, I'm talking about that actual length of that arrow right there. That's the vector. You can call this right here, when this is the tip of the vector, and where I stopped that arrow is the tail. Like tip, tail. The tail is where it stops. We're now trying to find what's that length. What theorem? Pythagorean theorem. Or you might say distance formula. Both of them work. And that's what we're going to do. I'm going to do the square root of the 1 squared plus the 2 squared. All right, how long is it?
Root 5.
That's the length of the vector. That's the magnitude of the vector. And we just put these bars around it to represent magnitude. So any of those bars written around any of those vectors will represent your magnitude.
So do you have to like, it's going like northeast or something, or?
That's right. You have to put that though.
Okay.
I bet you and I could figure out the angle if we wanted to.
Yeah.
You know, like inverse trig function. There you go. Excellent. All right, so and that's the magnitude of vector A. What would be the magnitude of vector B then?
Same.
Yeah, same magnitude, same direction. Outstanding. Well, cool. Well, how do you add vectors? What if I want to add vectors? Oh,